Hi there, and welcome to our IT Pro webcast, How to Design a Multi-Cloud Deployment, sponsored by Snapt. If you have any technical difficulties during today's session, please press the Help widget on your player console to receive assistance in solving common issues. If at any time you're having audio difficulties or issues with the advancing of the slides, please hit your F5 key to refresh your webcast console. Today's web seminar is being recorded and will be available on demand for 12 months starting tomorrow. You will receive an email when it is ready. Please feel free to submit any questions you may have for our speaker in the Q&A widget. Our speaker today is David Blakey. And with that, I'll hand things over to Dave.
Thank you, and good morning, good afternoon, and good evening, everyone. And welcome to part 2 of our 3-part webinar series. As mentioned, we have already done one of these. This is the second, and we'll be doing a third after this that I think you can sign up for. For new people, as mentioned, my name is Dave Blakey, and I will be talking about multi-cloud deployments. Sorry, I'm just getting the slides right here, jumping around a bit. And I'm the CEO at Snapt, a technology company that deals a lot with clients that have multi-cloud deployments and enabling multi-cloud deployments. And I'll recap quickly what we discussed in webinar 1, just to catch anyone up who happened to miss that, or anyone who did see it and doesn't remember. Essentially, what we spoke about was that the majority of organizations are using multiple clouds already, and that various security DevOps challenges exist in those multiple clouds. There are many opportunities presented by a multi-cloud deployment, but challenges as well. And that it is critical for performance, cost, and availability to be looking at a multi-cloud deployment. So what do we mean by multi-cloud? Seems kind of obvious. Means more than one cloud. But when I speak about multi-cloud and when companies like Snapt talk about multi-cloud, we're really talking about the idea of having your business critical production workloads running in more than one location. So it's all the way from co-location to true multi-cloud to hybrid cloud to public and private cloud and everything that's involved in the idea of having more than one provider for the services you use, for reasons such as redundancy to picking the best of breed service and everything in between. So really, multi-cloud to us and enabling multi-cloud and the challenges of multi-cloud are around these different platforms with different apps and different stages and different locations around the world. So what we're going to talk about today, the main focus of the webinar now, is the second part of our series on multi-cloud, which is the assumption that we agree that multi-cloud really is a direction that all organizations are going, and how do you plan for or better embrace a multi-cloud strategy in your company, right? So we're going to look at what to use multi-cloud for, how to choose between multiple cloud providers, how to deploy to multiple cloud providers, how to then secure them and think about security across different providers, and then a little bit of insight into how Snapt does it in our organization. Part 3 of this webinar will actually show you our product and how we'll do a screencast and how we use it in order to enable some of our multi-cloud workload. But in this, we'll just give you an idea of what a large-scale multi-cloud workload looks like at a company like ours, for example. Our use case, not our product powering it. So the first step, what to use multi-cloud for. What are the benefits of multi-cloud, right? And what do you need to be looking at it for? What are the kind of the low-hanging fruit, if you will? Obviously, we're of the opinion that all organizations should really be preparing for or already using a multi-cloud strategy. As you saw, some 81% of organizations are already in multiple locations and clouds. But the common benefits and kind of the easiest upsides, I think, are what I'd like to focus on first. And the first one, by far, probably the biggest, I think, where we see clients going to multi-cloud first, and the most immediate kind of return, I think, is for redundancy and availability. Now, I think the most important point here is clouds fail and network paths fail, right? So a cloud availability zone could go offline, and an entire cloud provider could, in theory, go offline. You can see in the figure on the top right that out of 1,200 respondents, 27% said they have no downtime per month from cloud providers. So the vast majority experience some amount of downtime each month from outages at cloud providers. And when you look at large organizations, you might not just be looking at outages in terms of availability zones or data centers going down, but also just system outages, right? Losses of virtual machines or instances or services, they do happen, right? Clouds have a 1% to 2% failure rate per year. So if you've got hundreds of systems, you are looking at a situation where they will be failing throughout the year, on a daily basis almost if you're large enough. And that's the critical kind of component here. I think in the last year, we've seen a lot of this, right? A lot of outages at clouds. From fires at providers to network outages to power problems and the like. And I think a real high availability strategy today must include a multi-vendor strategy, right? It's very hard to say that your application can guarantee 100% uptime if you're dependent on one single provider or one single network, or even worse, one single data center. So some of the challenges that we'll look at, when we really talk about multi-cloud challenges, especially like security and things like that, we're talking about, using Amazon and Azure and GCP and DigitalOcean and Linode and all of these cloud providers, or Amazon and your own VMware data center or whatever it might be. But even within one provider with multiple availability zones, there are challenges around redundancy and availability, right? Very common for us to see clients that have a deployment in Europe and one in the US. And if the US should go down, American users should be sent to Europe. But that still doesn't come for free, right? There's a design element that's really important there. The next biggest driver for multi-cloud that we see are geographic considerations, right? More and more workloads today are very latency sensitive, and getting traffic to consumers in the lowest amount of time possible is critical for all sorts of different methods, from things like finance to online gaming to gambling, sports betting, even just websites, really. But when you look at 50 millisecond or below latency, you're basically talking about geographic considerations, right? To give you an idea, to get to the west coast of America from South Africa takes 300 milliseconds if you have no delay. It's just that far. So there's simply no way like that an Amazon deployment on the west coast of the US can provide a 200 millisecond SLA to clients in Southern Africa. They would have to deploy in South Africa. Now, until recently, the only public cloud available in South Africa of the big three was Azure. So you could be an Amazon shop, bring on a big client in Southern Africa who requires a sub 200 millisecond reply on an API of yours, and all of a sudden you have to deploy into Azure as well, because there's simply no Amazon data center there. So we see this kind of thing a lot. It's not just a global problem, it's an in-country problem as well, right? Like in state, for example, how do you deploy this workload in that specific state? And that really drives people towards multi-cloud. And remember, the way I talk about multi-cloud is, deployments in many places, right? You might find that there's no feasible cloud in a state you need to deploy in that you could use, but there is a data center or whatever. So you ultimately wind up with the same problem. But this is rising big time. The need to have systems within, we used to call in old days the last mile. It's obviously not a physical mile, but within the last mile of the consumer is a big trend and a big concern of a lot of application types. The next one is cost and feature options. So the best possible cloud for each workload. It's easy to say, but really it's talking about using the most optimal solution for each problem that you have, right? Problems typically being your applications, but an application is many things. It can often be a SQL database and a key value store and a bunch of web servers, or it can be serverless, or it can be, just general purpose workloads. But you can see at the top right, the costs No one cloud is cheaper than the others, right? It depends on what you need, what instance size you're launching, what services you need to consume, and so on. And really, if you have a truly multi-cloud workload or application delivery strategy, there's no reason why you can't always be deployed in the cheapest cloud. It's like something of a shocking example to people often, but we have a client, for example, that spends $5 to $6 million a month on cloud, and they will move their workloads between the big three clouds multiple times a day, depending on the rates that they get, or their spot pricing, or the instance requirements, or things like that, right? So that's obviously an extreme example, but there's really no reason why you shouldn't be able to benefit from that. The other thing to remember is that cloud can become a platform for you. You might have an entirely containerized workload where you really can deploy it anywhere, and then there's no reason not to just say, well, run more containers wherever it's cheaper, right, and so on. And the final point, and this is an important one, is avoiding vendor lock-in. So when you design for a single cloud, you tend towards a vendor lock-in problem. It doesn't mean you definitely have one by working on one cloud, but you start to utilize local cloud services and applications, right? Products that only Amazon has, or an API that's very specific to Azure, or GCP, or whatever it might be. And it then becomes very difficult to get away from them. So what happens then is, your business is looking to be acquired by someone, but they need it to run in a different cloud, and it's not easy to migrate, or that cloud's pricing changes, and all of a sudden it's not the best option for you anymore, but you cannot move your workload off because it's become so dependent on it. These are lessons that we as an IT community learned long ago, right? With like SQL providers and things like that used to be locked in and you could never leave them, and no matter what happened with the pricing or the infrastructure or whatever, you were so deeply involved with their specific APIs and services that it became impossible to get off of them. There are deployment models that are helping with this natively, like being able to deploy things into Kubernetes, and then that's very much more easy to lift and shift. But designing your application with the intention of running it in more than one provider really forces you not to become locked into a vendor, of course. So this is more like a side benefit, I think, of it, but it is a big concern. You'd be surprised, I'd say more than 50% of enterprises we speak to are actively working against being locked into a specific vendor or provider. It also even helps with just, negotiating deals and prices, right? Like if they know you cannot leave, it becomes much harder. So the next topic is choosing cloud providers, right? How to choose the cloud providers for your business when you're looking at these multi-cloud strategies. Often you will already have one, but how do you choose the second one? Or how do you choose many, etc. And I think the first, my first tongue-in-cheek point would be really, firstly, don't design for specific clouds. Don't choose two. Doesn't mean you can't pick two to run in today, but don't choose two to build for. Build, in such a way that you could run in any environment is the key, really, I think, because that helps you to avoid these lock-in dangers. And then, it also helps you to build for like non-restricted environments and platforms, right? Like I said, like Kubernetes, where you can, ultimately design your workload for anywhere, or containers, or even virtual machine images. It all depends, can you use relational database services in a public cloud? Yes, because almost all public clouds have them. But as you go down that kind of, vendor-provided set of services, you obviously become more and more locked in. So the first thing is, I think, don't choose cloud providers as a part of your application design or work or deployment architecture. You can choose them based on what the cheapest one is, what the closest one to your location is, what the latency is like, what the quality of service or support is like, or what the contract you got with them is. I don't think you should choose them based on technical requirements whenever possible. The next point is to plan your architecture. This is a big important part that I mentioned, right? Location and requirements. So where do you need to physically exist? Where will it benefit you most to exist, right? Maybe you're looking at a multi-cloud strategy for redundancy and reliability, high availability reasons. But your business has clients primarily on the West Coast and East Coast, then you should deploy on the West Coast and East Coast. If you've got a lot of clients in the UK, Maybe it would be a good idea to have a data center in Europe. You know, a lot of these things you get benefits for free, right? You need 2 data centers for reliability, but you also then get to have better performance in Europe because you're sending Europeans to a local data center. So I think that's the big thing. And then I think, you know, depending on your workload, you really should look at the costs, right? There are wildly different costs between cloud providers, especially when you start to look at an enterprise workload. Egress fees can be extremely expensive. You know, the fees on ingress, WAFs, or load balancers can be extremely expensive. This is not an example that's specific to just Amazon, but by, you know, way of example, if you had, say, 100,000 new connections a second to an ALB system in Amazon, just the load balancing and WAF of that could cost you $20,000, $30,000, $40,000 a month. So as you look to scale up, you know, you can get a fright, basically. And you should really look at the underlying costs, right? Not how much is my VM per month, but, you know, how much data do I transfer, and will I ultimately get charged for that? And how much database storage do I need? My backups, how will I be keeping them? You know, what are the size of my files? And that's where people often get caught up. So looking at that. And then the other thing that this really allows you to do is what we call staging clouds. This can be a big cost saver for an enterprise. So when you have an environment that's not vendor neutral, cloud neutral, you typically have to have your test, staging, pre-production environments in the exact same cloud. Because if you're using their services, you have to be in that cloud to use those services. I mean, you don't technically, but you have to be using those cloud services at the very least, right? Having a cloud neutral strategy means that you can deploy staging or test environments onto totally different clouds. Now, of course, you will typically want to have some sort of pre-production environment in your actual production environment, but there are many companies who will deploy their staging systems and CI/CD infrastructure and things like that somewhere like DigitalOcean, where the infrastructure might be, you know, 2 to 3 times cheaper than AWS or GCP or Azure, you know, or maybe there are other clouds, right? There's Linode, there could be VMware, your own infrastructure. You know, you could do it on hardware locally, right? You could have your local Kubernetes instance that you run everything on because you're not tied to a single cloud. So staging clouds and stuff like that can be a big cost saving as well when you're looking at planning your architecture around these types of things. Next thing is to ensure your requirements are met. I've mentioned some of these things already, but you need to look at databases, right? Many clients will rely on the cloud provider to provide relational database services, as well as NoSQL, key value stores, things like that. And they vary quite a lot between them. You know, there's a good 20 to 30% variance between them. Egress data fees can be very different, right? So that's the cost of sending data out of your instances. And it costs a lot in cloud. If you're sending a lot of data, it can catch you by surprise. Your staff abilities and training, this is something that people don't talk about enough when they talk about multi-cloud, in my opinion. But, you know, if your staff are familiar with Azure and GCP, then that's the 2 clouds that I would pick first. Those would be the 2 low-hanging ones. There's no need to deploy to a cloud where troubleshooting will be hard or where you need to, you know, upskill your staff and train them and things like that. I think more so you really want to have a neutral experience where you can use whatever clouds are appropriate, but there's no need to you know, pick the one that no one understands. And then you also need to consider, especially at larger enterprise, regulatory requirements, right? For example, maybe you're working with government and you know, you need a cloud provider that has an acceptable environment for you to deploy into for federal work or things like that. Another big thing that we're seeing lately is data sovereignty, right? American companies want to know that their data is stored on servers that are in America. European countries might want to know that their data is stored in Europe. Australia, you may need to keep it in Australia and so on, right? So a lot of the time where we say, you know, this last mile deployment style can also be because, you know, if you want to do business with the Australian government as an American company, you may well need servers that are deployed in Australia. So, what are the regulatory requirements around that if you plan on doing particularly government business, but you may have regulatory requirements on your business that only certain clouds provide, right? Like PCI DSS, or how easy will it be for you to get SOC 2 compliance on a cloud? And all of those types of considerations are also important. Another good point about why it's nice not to be tied into a cloud, right? Because if you ultimately do need to move for some outside consideration like that, then it makes the whole process much easier, of course. That takes us to looking at some of the commercials and the differences, right? Contracts and commercials between the different clouds. It's very common for large consumers to get better deals with different clouds by signing contracts and things like that, but also the various types of support you get per cloud is very different, right? So SLAs might be different, the fees might be different. You can see that they can scale up a lot, right? This particular cloud example is $15,000 a month for 15-minute support, right? Now, if you've got 100% SLA guarantee or, 5 nines, you need 15-minute support. So then you need to account for that, right? What are the reliability and performance guarantees they give and so on, And how does that affect the SLAs that you ultimately have to cover? Because as you saw on one of my very first slides, 23% of clients or 27% of clients that haven't had an outage this month in public cloud. That's enterprises, right, with big workloads. So, you really need to consider that. I think is quite important. I see, by the way, quite a lot of questions are coming in. Just a reminder, you can keep typing your questions away, and I'll happily answer them at the end. I'll make sure that I leave a window because there are quite a few already, but feel free to just type them in as we go. The final point on this, on my kind of main tips for choosing cloud providers, is consider two times clouds or one cloud plus X, right? What I mean by this is, do you want to run your workload in 2 different hard clouds, public clouds, right? What you think of when you think GCP, Azure, AWS, Linode, DigitalOcean, etc. Or one cloud plus X, hybrid environments. This we see a lot, and went through like kind of a bit of a wave, or should I say like a valley, where in the beginning of people using more and more cloud consumption, hybrid was very common. Hybrid being that you had physical data centers or on-premise workloads, and you also had public cloud workloads, right? What I mean by the valley is that kind of started to shrink down. And now we're seeing a big uptick in that in cloud plus X. And often it's like A, B, C, D, E, F, G, much more than just X, because people are putting workloads on edge deployments, or people need, custom hardware for certain types of workloads where, hardware is much better, or they need GPU workloads or whatever that might be. But, like I said, I think multi-cloud and the story around multi-cloud is a good one because, 70% of people will just be in multiple clouds. Don't necessarily restrict yourself to just clouds when you're looking at deployment types, right? Data centers, app-based services, right? Places where you can deploy apps as a service and they scale them for you. Infrastructure as code stuff, serverless things. There are many different ways of deploying an application in multiple locations and handling that kind of thing. So the next thing is how to deploy to multiple clouds. And what to think of. Now, in the 3rd webinar in our series, which will also be public, you can sign up for, of course, we'll be looking at an actual demo of how we do it, right? Looking at our systems, how we route traffic around the world, what we do, what we monitor, all of that stuff. And it will be quite interesting. So I'm not going to go into too much detail on that. I'm rather going to say just how do you think about deploying to multiple clouds, right? And the first thing is, again, to consider your architecture. So VMs are very different from containers, Kubernetes versus monolithic environments, right? So, when you're deploying VMs to multiple locations, they obviously need a lot more consideration than just containers. Well, sometimes containers can be actually much more work, I suppose, but it really depends on what you're deploying into what environment. And a lot of the time, we got told this kind of story long ago that hardware was dead and everything was going to be virtual machines. And then the next part of the story was that virtual machines were dead and everything was going to be cloud. And now the next part of the story is that cloud is dead and everything's going to be containers, and straight container orchestration is dead and everything's going to be Kubernetes. And the reality is, across all of our clients, what we see is a spectrum. They've got hardware workloads, they've got VMs, they've got mainframes, they've got containers, they've got Kubernetes workloads, they've got serverless, they've got VMs, cloud instances, and I think that's here to stay for a long time. And like I said, we are seeing more and more hardware workloads and more edge workloads. So it's not just, well, people are slow to get to cloud. I think the real key is, what does your infrastructure require? How does it get deployed? And how do you ultimately deploy to it? The next kind of point there is to automate absolutely everything you can around deployments, right? So like for us, for example, we have a CI/CD environment, so we continuously deploy, and it does our entire deployment chain for all of our applications and systems and servers and sites and everything around the globe. All are automated from our repositories, right? Now, that's not always the case for every business, but as best as you can, look for tools that will allow you to, automate the deployment process into environments, especially where you can define those environments through config files and code and APIs and things like that, right? Where you can integrate them into your test environments and your continuous integration environments and so on, and deploy automatically into these different cloud providers. So things like Terraform, for example, make it very easy to take complex systems like full stack VMs and deploy them into 2 different cloud providers, and configure them to use the local, deployments and things. So it's not, just that containers are the answer, for example. I think that, the automation process of it is very important. And also knowing that everything has to be automated really lends your team towards building and designing your application infrastructure, and even your developers to developing it in such a way, if you have developers, that it allows automation and easy testing and ease of deployment and things like that. Automation is also incredibly important when you scale a business like ours, for example. 6 or 7 years ago, we maybe had 10 servers, running our business around the world. You'll soon see we have hundreds now. And it's, when you need to scale up rapidly, it really helps a lot. The next point is to utilize auto-scaling functions where you can. So one of the problems with costs around high availability and multi-cloud strategies is that if you deploy the same environment into 2 places, generally speaking, you'll be paying twice for it. And it gets much worse when you deploy it into 50 places. We've got clients, for example, that have got somewhere between 12 and 14,000 applications running in 60 countries. They've got 450 ADCs of ours, and behind each ADC, they got an average between 10 and 20 servers. So, do the math, right? It becomes a real nightmare in terms of cost and scaling and management and so on. Auto-scaling is something that exists in all orchestration platforms and in most cloud platforms. And if it doesn't exist, it can be scripted and tooled in quite easily. And what it's really saying is, well, let's take a simple example. You've got a website, and depending on how busy your website is, depends how many servers you need. Now, that website can no longer afford to fail, right? You can't afford to have an outage, so you decide to deploy it into 2 different locations. But in your example here, you send all of your traffic to your New York data center, and only if it's down do you decide to send it to the New Jersey one. There's no need to have the same number of servers running in New Jersey as you do in New York when the New York system is online. And this is a key consideration of multi-cloud deployments. Even if you've got an active environment like we do, where all of your servers could receive traffic at any point in time. Our workload right now is largely in the US. But 2-3 hours ago, it was a split between the US and Europe. 6 or 7 hours ago, it was largely Europe. And so, your systems can scale up and scale down as needed during those times, right? A simple example is something like, Black Friday or Cyber Monday, right? Do you really need to run as many servers as you need on Cyber Monday all year? Obviously not. But clouds, support these types of functions, and I think it's important. And it also allows you to make sure that, should say AWS fail, that your GCP environment is ready to scale up to potentially double the size that it's ever been to handle the incoming users that can no longer get to AWS. So it's really a high availability function as well, and very useful, and then ultimately saves you a huge amount of money, of course, because most of the time your environment hasn't failed, of course. The next learning and advice of ours is to route traffic with GSLB. GSLB is an acronym, stands for Global Server Load Balancer. It's quite a simple concept, really, but what it is to do with is having an intelligent DNS server or service. There are many companies that provide it. Most clouds provide it. Snapt provides it, for example, that will route people to different locations around the world or data centers based on some information about them or about the place that they're trying to go. So DNS normally is the process of saying, okay, I'd like to go to www.snapt.net. And you leave your house or office and you go directly to the IP address that snapt.net resolved to in a data center somewhere. Once you arrive in that data center, it's the first opportunity that we, Snapt, have to change your direction, to send you somewhere else. So if you've arrived in US West, it's like too late now to send you to US East, right? Because the first time we see your traffic is when you arrive. So it's like trying to manage a traffic jam at the toll gate. It's very difficult at the toll gate to move people to a different road or interstate or highway or whatever it is. Or at the front of the traffic jam. If there's been an accident on the road, by the time people get there, it's very hard to move them. What GSLB is about doing is changing where they're going when they leave the house. So it's telling their GPS to send them on a different road, right? And it lets you respond to DNS queries for a site or many sites based on the health of the destination. So you can say, well, is this data center online? How busy is it? Is it saying that I should shift traffic elsewhere? Considerations like that. Is it dead, right? And also based on the source of the user. Where are they? Where are they from? What's their network range? What country are they in or city are they in? And so you can say things like, well, okay, someone has come in and is trying to get to api.snapt.net. Now, where's that person from? Okay, San Francisco. So we want to send them to our West Coast US data center. Then let's also say, is the West Coast US data center online? If so, cool, we're good. If not, send them to the next closest data center, New York maybe. Or we might say, well, this user's not from America. Where do we want to send them? Things like that, right? So GSLB, very powerful system for being able to move between multiple clouds. It's a great enabling way of doing that. And it allows you to do things like test deployments very easily. It allows you to weight things very easily. So, you might be saying, okay, well, how do I get to this multi-cloud dream that Dave keeps going on about? I'm going to set up my infrastructure in Azure as well. So we're not just in AWS anymore. We're now launching in Azure. How do I send some traffic there? Testing is obviously testing. But when you start to go to production, what do you do? So GSLB makes it very easy to say, cool, I'd like to send 5% of my users there. Or just users from our office there, right? So you could put in your office's IP address range and say, well, send all my office people, without even telling them, to the new data center and see if they complain. See if I get any alerts or things like that. So it really makes the function of interacting with multiple clouds much easier. And by the way, we will actually look at a functioning GSLB setup in the third webinar. So you don't have to worry too much about watching any videos or anything. We will go through that. So the next thing to talk about is how to secure multiple clouds. And this is hard. It's hard when your security is advanced. It's easy when your security is basic. But all security is having to become much more advanced. So why do I say it's so hard, right? Because security solutions now are no longer about layer 4 traffic control. So layer 4 would be IP layer, right? So, is this IP address allowed to go to that IP address on that port? Like classic firewalls, right? But much more now, they're about layer 7, which is what is the user actually asking for? And then above that would be, all of the kind of security techniques that companies like us are employing now, which would be machine learning, anomaly detection, etc., for traffic patterns. As you scale to multiple clouds, it becomes extremely difficult to do that kind of thing, because in the example I used of the very big client of ours, where they have 450 ADCs around the world, it's almost useless for them to operate as individual islands, looking at just the data that they see. They're only seeing 1/450th of the data, right? And when you move to multiple clouds, this can be a big problem, and especially as you scale up, right? So the first point that I have is to look for cloud-neutral solutions for layer 7. Specifically layer 7. You'll see I suggest cloud for layer 4. So what I mean there is the application layer, right? Your things like web application firewalls, intrusion detection systems, SIMs, all that kind of stuff should be able to run in any cloud container, edge, device, hardware solution, anything. It's critical if you want to actually actively manage the kind of threat profile and risk of your network, that you are running that solution in every location in your network. It's not much good having a very intelligent solution in one cloud when the other one is not, or when the two clouds cannot communicate with each other about threats, or when no one knew that half of your office was sending data to ransomware sites for the last week anyway. You really need something that's neutral, right? So able to run anywhere. It should have full support for cloud-native environments and monolithic environments. This is like such a problem that I see in the industry. People are either going to your more tried and trusted vendors in the industry who are more likely to run on monolithic environments, or these new shiny solutions that only really work well in containers, for example, or in Kubernetes. And the reality of like all corporate workloads is that it's all types of things. And then I think it's very important to support your CI/CD environment, your disaster recovery and test environments, etc. Like I said, it should be able to run in all of those locations, right? That brings me to, I think, the biggest learning we've had building a large-scale multi-cloud organization is centralized monitoring. The ability to track, visualize, and verify everything in one location, right? Like the nightmare when you have a large network like we do of someone saying, some of our users in South America, or even worse, someone says, we've got a user in South America who says they're getting a 500 error when they try to log in. And you're like, okay, well, that's kind of odd. And then lo and behold, 2 more tickets come in from 2 more users in South America who are having errors, right? But you look on the system, looking through the system, and you notice that there's 300 South American users online that seem to be working fine. Where are those users even going? You don't have servers in South America? Are they going to the west coast of the US or the east coast of the US? And then you begin grepping through logs, and it's completely unmanageable, right? And it leads to things like what we call tribal knowledge, the idea that there are people in your team that have knowledge that other people in the team do not have. And staff retention is crazy low in DevOps, IT ops, all the way up to CIO level in our industry. In the Valley, for example, our client types, staff retention is about 5.5 months. So it's very difficult to have people that have scripts or tools that are not accessible across the business, right? So central monitoring is key between all these environments, which really does lend itself to a cloud-neutral, vendor-neutral solution, because ultimately you know you're going to be deploying to multiple environments and locations, so you need something that can monitor across all of it, right? So that's a key learning of ours. And then I believe that you should use the local cloud services for layer 4 solutions. So there I'm talking about firewalling and things like that, right? What security groups can access what security groups, what IP addresses are allowed in on what ports are not allowed in no matter what you do, etc. Right? Your standard layer 4 firewalling. A, it's really a commodity and it's very cheap to use public cloud for that. And B, it's very easy to do with security groups and services like that. And I don't think that it requires so much maintenance at a layer 4, at an IP level, that you have problems between clouds. What I mean by that maintenance is, the worst is when you have a new SSL certificate now, let's say, expiry on your SSL certificate, and you have to update it. And where in all the places is this thing used? Which cloud do you ultimately forget to put this thing in? Or which application do you find out at 12:01 tonight it's got an expired SSL certificate because you didn't put it there? The beauty about layer 4 is that typically you are basically just saying, deny outbound access from my systems out unless someone sends something in or they're doing an update, allow in port 80 and port 443, web, HTTP and HTTPS, maybe allow in some other port from our office IP range, and it's pretty static, and you kind of leave it at that, so it doesn't become this nightmare to manage. Layer 7 really does, where, for example, let's take that large client again, 450 devices around the world. They decide, as of the beginning of next month, we're not supporting TLS 1.2 anymore. It can be a huge process to disable TLS 1.2 across an entire organization, right? So that's the layer 7 consideration, where I say that you should use cloud neutral solutions. This slide, of course. And then layer 4, when you're talking about pure IP, I really recommend using the native cloud solution, of course. The next thing I want to do is a small preview of how Snapt does it. This is what we're going to be looking at in our next webinar. Now, we'll be showing you our product, obviously, which is largely an enabling factor of that for us, but also just like our learnings and how we actually deploy and where our systems actually go and how we use GSLB and what clouds we're in and what services we use from different clouds, and when and why, right? So this is just kind of a quick preview at that. I'm about to then tell you what's going to be in the next session, and then I'll start doing some of your Q&As in a second. So the first thing is our live network. This is from yesterday, but these are our live systems and deployments for our organization. So there's about 500 and something online servers or containers that are, managed directly by us in order to deliver the services that we do. So you can imagine the complexity there, right? You can see in South Africa, for example, bottom middle of the map, in 3 different locations, which are all 3 different providers, and only one of them is a cloud provider. Across Europe, a lot of those are data centers. US, a lot is data centers, a lot is public cloud as well. You can see South America, Australia, etc. There are many, many, many organizations that we work with that wind up looking a lot like this. And needing to cope with these types of challenges, right? How you manage an organization at this scale. So our key takeaways, I've mentioned a lot of that already in this kind of presentation, is that we use automation for absolutely everything. So there are no manual deployments of any websites, applications, APIs, services, anything that we provide at all. It all goes through a CI/CD environment and then is deployed automatically. We avoid cloud-specific tooling completely. So we don't have a single script that interfaces directly with any one cloud provider's API. We do obviously in our product because we provide that service for clients, but our deployment process is not tied to any specific cloud. So it is possible to do that relatively easily with the right design, right? We distribute our traffic globally with Nova, our product, which we'll be looking at next webinar. And we secure everything with the same product. And then we use that product for monitoring, visibility, etc. So we have a central dashboard where we monitor basically our entire infrastructure, which we'll be showing you. I think the most important lessons that we have, the most important kind of advice to give here is really that we do not develop anything that has a specific cloud provider's name in or platform provider's name in, right? We don't want to use their direct APIs wherever possible, and that we automate absolutely everything that we can. So just before we get to the questions, our next webinar, you can sign up for it. It's the final one in the series, and it's going to be the first time we actually look at anything that we do specifically with our product, and I think it will be quite interesting for you. So it's going to be a live demonstration of our platform. I'll actually be sharing my screen and talking you through how we deploy things, how we set things up, how we route our traffic, what outages we've had, how we've accounted for them, where we typically see outages, things like that. For example, there was an outage between Australia and Europe. And for some of our services, we use Europe to service Australia for certain workloads on the same night that Facebook went down. And it was extremely difficult to find people talking about an outage that was not Facebook. So we'll be talking about how we detect that, what we saw, things like that. How we deploy to multiple clouds, how we secure and detect threats across different clouds, right? Like I mentioned, if I am doing something simple, most attacks nowadays are much more advanced than this, but just scanning your system for vulnerabilities, trying to find out if you run WordPress, whatever it is, right? It's entirely possible that if you have a more advanced layer 7 security solution, it will pick that up at your first cloud provider. When I switch to your second one or your second data center, is it going to know about me already or not, right? That type of thing. And then global routing and visibility. And basically how to get the benefits of multi-cloud while skipping some of the challenges and costs and learnings that we've had along the way. So those are my main tips on how to design a multi-cloud deployment and what to worry about, what the low-hanging fruit is, what the concerns are, right? Looking for redundancy and availability, geographic considerations, and cost options while avoiding vendor lock-in. That's really what it comes down to and allows you a lot of flexibility, right? I think at this time we'll move on to some of the questions. There are quite a few, so let's just get started, I think. Cool. So the first question we've got here is, what clouds do you recommend for a startup looking at just 2 clouds? Okay, so this is, it's quite difficult depending on what your workload looks like. But generally speaking, as a startup, I would say pick 2 big ones, or 1 big one and 1 more cost-efficient one. So the reason that I say that is because the big ones, it will be very likely that people you hire, and as you scale, people will be familiar with them, right? So pick Amazon and GCP, or Azure and Amazon, or GCP and Azure, something like that, right? The biggest kind of awareness in the industry when you're hiring people will be Amazon. So, AWS, most people will be familiar with. And then your second option, I think, really of a more cost-effective cloud would be picking one of the big 3 and then picking something like Linode or DigitalOcean for your second cloud, because it will allow you to be more cost-effective and run cheaper tests and things like that in the environment. So it really depends which way you want to do it for that, yeah. Okay, I think Emily is going to ask the next questions.
Okay, so next question for you, Dave. So what if we are already using a lot of AWS services?
Yeah, so then it's difficult, right? So there's multiple things I would say there. Firstly, evaluate the services you're using. If you're using a key value store like DynamoDB, simple email service, or SQS, and you're using their relational database service, all of those services are available in Azure and GCP. Hopefully you're using like a neutral API to interact with them. Most frameworks, applications, platforms will support using any kind of, just general SQL database. So it might not be as bad as you think. If you're using a lot of their services, then it will be more restrictive, right? So then you want to think about, do I have new workloads or applications or services that I'm launching, and can those begin to live in multi-cloud? Or can components of your current infrastructure start to live in multi-cloud? I think it's a journey. It's not a single button click. And in my experience, the easiest way to do it, if you do have that opportunity, is to do it with something new. And then, to migrate the older stuff over time. That would be my general advice. But I think for a lot of people's workloads, the services that they're consuming from the cloud provider are available in other cloud providers. Maybe not every location, which is the problem. They might not be available in data centers or in containerized deployments, but it's very likely that they are available in some fashion in one of the big three.
Okay, great. Where do you recommend hosting Kubernetes workloads?
Basically anywhere. So it depends how familiar your team is with it. Are you going to run your own entire installation that you manage yourself? In which case, you can probably run it on whatever the cheapest compute cost is that has the best reliability and support attached to it, right? Don't pick a data center that goes down more often than others if availability is important to you. But if you're looking at a managed container platform, there are then much fewer options, right? There's managed Kubernetes on GCP, DigitalOcean, Azure, I think Linode. Amazon has Kubernetes services and their own EKS or ECS services. So it really depends. I think, where do I recommend hosting it? I guess it's in 2 different clouds, right? That's what I recommend, obviously. So, I think it just comes down to what location suit you, what your team's familiar with, that kind of thing. But I think most of them will support it. And what's nice about the Kubernetes deployment style is that you can move at any point in time.
Okay, great. And to go back to an earlier point that you had made in your presentation with some clarification regarding vendor lock-in, are you suggesting it's cheaper to deploy in all database models, all spreadsheet vendors, et cetera, to avoid being hit by potential price increases? Or do you recommend co-deploying a cheaper dev versions of the prod app and then switching your prod instance to a chosen dev replacement of the month?
Oh, it's a mix, right? So I think my real point with vendor lock-in is don't expose yourself to, let's say, hypothetically, Amazon doubled the price of their services and your business's margin was like 2 or 3%. Would you have to shut down? Now, I know Amazon's not going to double the price of their services, but I think, the thought experiment is what it's really about, right? How does that impact you? You could get acquired by another company and need to move clouds. It could be whatever. So what I'm suggesting is to avoid practices that are associated with vendor lock-in. In terms of how to actually benefit, I'm saying be deployed in at least 2 different vendors, right, for high availability. So at least 2. And one of the problems is that when you need to be deployed in 2, you may as well be deployed in 50 because then you already cannot be locked into one cloud to be able to be deployed in 2. Once you're deployed in 2 for high availability reasons, you can then really decide, what your priorities are, right? Like I say, your question was correct that there are cheaper clouds. Now, it's often very attractive to use a cheaper cloud for your dev and test environments. And maybe what you can do is say, well, I'll actually have my backup in that environment. And if my production cloud fails, we'll go to the cheaper backup environment because it will be fine for now. Most often you don't get that world. Most often you're saying, okay, I need to be in multiple locations because of performance reasons, or, I need to be fully highly available, active around the world. And that's where really, I guess, the cost savings of auto scaling come in. But the main point of vendor lock-in is it's not to deploy everywhere or to support every type of database or service that someone provides, as much as it is not to be restricted to one specific service that one specific cloud provides.
Okay, great. Going back to what you were just talking about Kubernetes, can we move our native applications to Kubernetes to ease managing and deploying it on a cloud?
You can, but it's not easy depending on the application. If you've got a website, it's quite easy to move that into Kubernetes. Sometimes not that easy to have, a highly available managed SQL database in Kubernetes, or even NoSQL if you need high availability and need to ensure you never lose any data. These are things that then become complicated. If you've got a very deep, tall monolithic app, sometimes it's not best. Sometimes it's better just to say, well, I can run this on a VM in Azure and a VM in Amazon, and then I'm sorted. But I do think for certainly web-based, API-based, microservice-based, or service-based deployments, I think looking at Kubernetes or containerized deployment styles is a good idea. It makes scaling very easy. When you are in Kubernetes, it forces you to adhere to basically every single bit of my advice today. It makes you do all of those things. But that's a journey, especially if you're in a company that doesn't have skills around that. So that's something you have to be very careful of, right? You might be a Kubernetes expert and you might be able to migrate your whole application stack into Kubernetes. But when you're away, will it be easy for your team to debug a problem or diagnose issues? So that's why I think it's really more of a journey. We'll typically embrace new technologies by, a new project will be started in that. And then the team upskills through that new project. But yeah, absolutely, you can do that. And I think many organizations are busy looking at containerizing their applications. It's also become like an excuse to modernize, right? It's like you rip this very monolithic kind of stack off of a bunch of servers that you used to run in and put them in VMs. And then you took that same stack and put it in the cloud. And, it's very resource inefficient. It's hard to scale, things like that. And then now containers, you're like, okay, it's finally time to rebuild the way we deploy the platform or the way it's architected. So sometimes that can be a nice motivator.
Okay, great. Looks like we have time for just a couple more questions here. Do you have to use public cloud to use services like GSLB, et cetera?
No, not at all. So, you can use a managed GSLB service like we provide with something like Nova, for example. Or, you can run your own GSLB. We have a product, Aria, which will allow you to host your own GSLB, or you could do it, with another application. And then you can reach just to straight data centers, right? Or to your company's local data center. It can be for internal traffic only. Essentially, it's just deploying a smart DNS server instead of what I would call a dumb one, but a standard DNS server. So no, it doesn't require public cloud at all. It can often be much easier to have someone manage the GSLB for you, though, so that they have DNS servers all around the world, and you don't want the GSLB infrastructure to become a single point of failure.
Okay, great. And it looks like one last question here. How would you deal with the ingress and egress traffic costs related to multi-cloud?
Yeah, so egress is the biggest one. I think, that's where you get stung a lot. So we see that a lot. And typically, we will deploy in a way that it is quite localized, the data in those environments. Obviously, we have to have, certain environments have highly available databases that are shared between the two or things like that. But we will typically try to make sure that the entire stack communicates all locally within its, local networking environment to communicate amongst services. And that the only reason for one cloud to talk to another cloud is if it needs to share database information, things that have state, right, between them. And that's even assuming you don't use some hosted cloud database or something like that, and a third-party multi-cloud database like a scaling database or something like that. But yes, the other way you deal with it is paying for it. So if you have a lot of egress between the two clouds, you wind up paying, and it does become expensive. So you just really want to deploy around that strategy. And unfortunately, it's something you kind of wind up paying anyway, because even if you don't go multi-cloud and you just stick with one cloud, I think the last year has shown everyone that you definitely need to be in multiple availability zones, and then you wind up paying for data transfer fees between them anyway, especially depending on what type of services you use. There's so many complexities, like you use API gateway at Amazon, and then, there's then actually additional costs if you go from an API gateway to a standard system, or, between Lambda and your relational database service, you get billed for the traffic, and, all these kinds of weird things. So, you're asking the right question, because, yeah, it can cost a lot and you need to be concerned about it, but it is just something you have to factor into it, I think.
Okay, great. Well, it looks like we are just about out of time today, but before we go, we'd like to thank you, Dave, for that great presentation, as well as Snapt for sponsoring today's webcast. As a reminder, we do have another webcast coming up with Dave, so be sure to register and attend. We hope you have a great rest of your day, and thank you for attending.
Thank you all, and look forward